Welcome to our channel. Hi there, my name is Ranjan. I am a full stack DevOps engineer with 11.5 years of experience working in IT. I am also a 4.5-star rated Udemy instructor teaching more than 72,000 students worldwide. On this channel, my goal is to make you learn and grow by sharing my experience. So if you like my work, then do like this video, share it with your friends, and don't forget to subscribe this channel for more such awesome videos in future. So let's get started. Thank you.
Okay, now let's try to understand what is lambda, what are lambda expression. So let me put the topic here, lambda expression. So this is another concept introduced in Java 8. But before we go to lambda, let's understand what is object-oriented programming. As you might remember, the object-oriented programming is a paradigm in which whatever we basically implement has to stick to the guidelines of object-oriented programming concepts, like it should adhere to programming paradigm, should adhere to classes, objects, encapsulation, the OOPS principle, encapsulation, inheritance, polymorphism, and abstraction. Basically, if you have to implement anything, you have to abide by this OOPS principle or OOPS concept. But there is another way to also implement this functionality in more clear and concise way. So that is called functional programming. So another is functional programming. Here, implementation of same functionality can be done in clear and concise manner. So concise manner, what does it mean? That the code will be less, implementation will be compact. So that's what the functional programming actually provides. If you implement the same functionality using functional programming, the code will be less, it will be clean, and it will be compact, so that you don't have to write many lines of code to do the same implementation. So let's try to understand this with an example that would be make it more clear, the concept. So let me create a package here. Let me call the package as lambda. Okay, and in here let's first create an interface. Let's create a functional interface that we have studied so far. So let's say I have a function interface called vehicle, and in that interface I will make it as a functional interface, so that I can only have one abstract method. So I will say public, or I can say directly void details. This is so now the error went away because, yeah. And now I will say I will also have a, let's say, a default method. So default void show show, yeah, get mileage. Let's say get mileage. This is a default method, and same way you can keep because this is a default method. We have to give implementation. So I will say system dot out dot println, and then I will say showing mileage details. Okay, this is an method. In normal regular Java, what we would have done to do the implementation for this one, we will have to go here and create a class called vehicle IMPL, which is implementation class, and then this class will basically do the implements vehicle interface, and then we will add an implementation here for the abstract method. Here we have one abstract method, so I will add an implementation here. I will say system dot out dot println vehicle details for implementation after implementation. So now let's say I want to do to test it, then I have to go and create another class called, let's say, with the main method class called vehicle main. I will go here. So I will say vehicle main, and here I will go ahead and create the object. Let's say like this, vehicle. I can create a reference of vehicle and object of this, or both. Let's say vehicle MPL vehicle equal to new vehicle. I should not do it here because this is a main method class. So let's create a main method class. So main public static. So let's create a main method which will trigger our program. So public static void main, and then I say string. Now let me put this GS, and then I will say system out dot println. Let's say main method, that is fine. And now we will say this way, let's call the vehicle, let's get the vehicle object, vehicle MPL vehicle is equal to new vehicle, and now we can actually use it, vehicle dot details. So to use this, to give any functionality here in this interface to this method, we had to create first an implementation class which gave the functionality, and after that only we can create the object of the implementation class and call that method. So we have to have some kind of a three-step approach. First declare here in the vehicle interface, implement here, and use anywhere by creating the object. So this is how we would do this using in the object-oriented programming way. If we want to go by the object-oriented way, like this one, object-oriented way. But let's see how we want to do it in the functional programming way. So I hope you understood the problem. The problem here is until Java 7 that you have to create one file to do the declaration, second file to do the implementation of that declared methods. Let's say this has, this will be abstract method. So you are giving implementation here, and a third class where you will basically get the object and use it. So until Java 7, this way you used to do that. But let's say now in Java 8 using Lambda, how will you do it in a different way, in a simpler way? Yeah, so if I come here, I would say, let's say this is the IMPL object, and then like this. So here what we are doing, we are creating the object, we are creating the reference of the class and also the object of the class. But you might already know that we can also do like this. We already know, we have studied it. I will just create the reference of the interface, but I will create the object of the class. We can do this also, and it will give the exact same thing. So I can call now vehicle dot details. So if I run this, I will get the same result. So let's see. See, we got the same result for this also. Can we basically do it in a simpler way or in a very nice way? Okay, let's try to see. Let's say I have this interface and I don't want, because this has only one abstract method, so I don't want to basically create this intermediate class to give implementation to it. What I want is wherever I will use this interface method, there only I give the implementation. So is it possible? And what is this? This is basically a method which is basically not taking any parameter, and it has a return type of void. So let's see if we can achieve that. So let's go and create another class here. Vehicle lambda main. Let's create this class, and here I will paste the public static void main. So what I am doing now is I go here and close this main method. So let me copy this. Or I will just copy this. I will write the other things for you. So copy, and here now we have our class. So we have an interface, and we directly have the main method class, no implementing class. So can I now in the main method class, here in the main method, directly somehow use the function, give the definition of this abstract method and also use it right away. So that's where the power of lambda expression comes. So here I can say vehicle equal to, which means we are creating just the reference of the vehicle, equal to what I will do, I will directly start giving implementation of my abstract method here. And what is my abstract method? It takes no argument and it has no return type. So I will go here and say no argument, and then I will write the code. So usually what I should do is I should go ahead and write details, void details like this. If I directly want to give the implementation here itself, I have to write like this, vehicle and then void the details and this. But we don't have to give the return type. We don't have to give the method name. We will just say bracket, which will take nothing because it is no argument. And then I have to give arrow. And here I have to go ahead and write the body. So what the body I wanted to write, let's see. In the implementation class, what we wanted to write, like this. So we will write exactly the same body, then and there, where we want to use it, then and there. So now what we did? So you can keep on writing. So if you have only one line of code, you can even get rid of this bracket. It's not needed. You don't even have to have this bracket. But if you have multi-line code, you can give this bracket. Let's run it. No compilation error. So now we can call our method vehicle.details. As soon as we now call this method, it is actually going to call this method here. See, now we are able to write this. Great. Can we have a calculator interface like this? So let's go ahead and do that. So I will say calculator, and I have, let's say, an addition here. So I will say add functional interface. Then I will say return as an integer, and then I will say add. Let's add to an integer num1 comma, I will say integer num2. Let me put it this way. So now this becomes our abstract method, single abstract method. So this can be declared as a functional interface. So now let's go ahead and let me try to use this. So I can create a main method class, or I can also use it here. So let's say here, what I will do, calculator equal to, because this method is taking 2 arguments, I have to pass integer comma integer. I have to say integer a comma integer b, and then like this. Then I can say return a plus b. I can do this. Now let me say let me store the result. Integer result is equal to calculator dot add, I will say 5,7. If I run this, let's print the result, system.out.println, and let's say result. So let me run this. So we get the result as 12. So now what is happening? We, at the time of declaration or itself, we are giving the definition to the single abstract method. And now, if you have one line, you can get rid of this. But if you have only one line also, you can even get rid of return statement. If you have only one line, then you can get rid of curly braces, but you can also get rid of the return statement. Automatically, it will infer from this interface whether there is a return type or not. So let's run it. Let me change it, let's say 9 here. So now expected output should be 14. Let's see. So it's 14. So you can either do this, copy, I will paste it here and put a comment here, and maybe I can do this also, this. And I will say return. So both are allowed. So this is how you can simply, you did not have to go by creating another implementing class, give the implementation of this add, and then create a main method class, and then create the object of it and then call it. So we bypass the normal object-oriented paradigm. We directly used functional programming, and with the help of Lambda, this is called Lambda. This way of writing in single line, giving the implementation of a method is called Lambda. So with the help of Lambda, we are able to achieve the same functionality, but in very simple, in one line. That's it. In one line, we are able to achieve it, rather than creating a class, giving implementation, creating another method here, like here, and then creating the object of it, calling the method. Not required. Very simple and concise way we can now give implementation to our single abstract method of functional interface and use them wherever it's needed. All right, so let's go ahead and check again how we write a lambda expression. So basically, if you see in very simple term, this method, this is nothing but an anonymous function, you can say. It is just a function. It is not having any name or the return type. It is acting like an anonymous function. Same here. You see, it's very simple. It is like an anonymous function. You don't have to have a fancy class declared and to declare that kind of method. So let's quickly check how we can convert or turn a normal function into a lambda function. So if I say, let's say there is a method here, a public void, and say method name is a test method, or let's say multiply, then you simply basically have to do few things to convert it into a lambda expression. So here, let's say you put system.out.println and you say I am a normal function. So let me convert this. Let's convert this into a lambda function. So first thing we have to do is, number one is remove modifier. Okay. Second thing what we have to do? Second thing we have to do is remove return type. Remove return type. Return type. Third thing that we have to do is remove the name of the method. Remove the method name. And then the last thing that we have to do is add arrow sign. Add arrow. Let's say it as arrow sign. Let's do this. So let's convert this method into lambda form. So first thing what we are saying, the remove. Yeah, so let's take an example of this one only, because I have to put it this inside there. So let me do it here. Doesn't matter. So first, what we remove modifier. So public is gone. Remove return type. This is gone. Remove method name. This is gone. What is left? Only this. So we just say argument list like this, and then add as arrow sign. That's it. And then like this. And this is our method. And now let's say I am a lambda function, and this lambda function, you don't have you basically just have to add the arrow, and other things are obsolete or skip. You can skip them. You even can skip this arrow, as I also mentioned earlier. This is also not needed. So you see, in very simple one line, you are able to convert this function to a lambda function. So let's basically, the reason why you are getting this error is it is not inside a interface. So I will let me create an interface here, function interface. So I will say multiply interface, and put this one inside that. So I will say functional interface, and then I will go here and copy this, cut, paste it here. So ideally we should basically have the lambda function inside, or basically the lambda function should be a part of a functional interface declared as a single abstract method. So I have removed that method from here, and what I did is I have created this new method, new interface called, let's say interface. I will say it interface. There was a spelling mistake, so let me refactor that here. So I will say interface. Okay. So now in this, I'm just going to put the same exact thing. So public void, I will say multiply, and here now this becomes a functional interface with a single abstract method. And now what I'm going to do is I'm going to go to my main class here, and here basically we will do the exact same thing. All the steps we will follow. Like what we will do, we will remove the specifier, we will remove the return type, we will remove the method name, we will only have this and put an arrow sign and write the logic. So that's what we did so far. And now this method will be as an, this method will be acting, the placeholder for storing this method is this one. Let's put it this one. This is the functional interface which is going to hold it. And now we can basically call that method from here. So we can say dot multiply. Of course, we are not doing anything related to multiplication here, but this is how you convert a normal method into a lambda function while giving the definition. So let me run it. So we have written in this, we have reused the same vehicle lambda main method, but that's fine for creating the objects. So here it says I am a lambda function. Let's say, yeah. So now we have converted it to lambda function. So I am a converted, let's say converted lambda function. So this is how you can convert a normal function into a lambda function by following these 4 steps. Yeah. So now this is how you can convert a simple single abstract method to a lambda expression or a lambda function, which is just a single line of code. And we have also seen an example of how we can basically have a, let's say, a parameterized method in the like in the example of calculator. We had two a number integer doing addition, and then we saw how we can convert that also. So we just dropped off the method name, return type, access specifier. We just kept the parameter list, and then we gave a arrow, and then because this is only one line, so we also skipped this bracket and return keyword, because it compiler automatically infers it by knowing that if the declaration here has a return type, so it is automatically going to return the value of the expression. So that's why this and this are exactly same. So can we make this even more simpler? Let me uncomment this one, and then I go here. Sorry, I will uncomment this and comment this one. Can I even get rid of this bracket? Let's see. If I put this here, it is complaining. But what if I go here in my calculator and make this as just, let's say just it has one parameter for showing for example purpose, then I can even get rid of this, not required. So this is a valid, then I have to send only one parameter and call it. So now our result will be whatever we are sending, we are returning it. Let's say I will do plus a plus a. Let's put it that way for showing purpose. So you don't even have to have a method, I mean a parameter. In the parameter list also you can omit the data type, but also the whole parenthesis also. So this will also work. Let's run it. See, a plus a 5, 5 plus 5, 10. So you can go to that extreme level. Just how simple your method implementation become. You can just imagine with the help of lambda function or lambda expression implementation. Let me copy this and change it back to its normal form, assuming that it takes 2 parameters. I'll comment this and let's give this one from readability perspective, and then I will go here and also change this one. Now everything is exactly same, but I will also paste this so that it is there for the reference. Great. So this is all about lambda expression and converting normal function into lambda function. Okay, now let's have a look. How can we basically implement our thread, which was using runnable interface, using lambda expression. So let's say a thread. Let's convert the thread we have, because we know that runnable interface is also an example of functional interface, because it has only one abstract method, which is run. So let's go ahead and create our thread, create our class which we want to run as a thread. So I will create class, let's say code to run as thread, as a separate thread. Let's call it this way, thread. That's a big name, but that's fine. It is good for as explanation. So let me create this class, and here we'll say implements, and we will say runnable. As soon as we do this, if we go inside the runnable interface, we see it's a functional interface, and the method, because it has only one public abstract method run, so it is a runnable interface. Great. So as soon as we do this, it will ask us to implement the run method. So I'm going to implement it here, and I don't need all this. I will get rid of it. I will give some logic. Let's say what I want to do is just I want to print from 1 to 5. I don't want to do anything else. For integer count is equal to 0, or let's say 1. I want to print 1 to 5. Count less than equal to 5. Count plus plus. And then I will just say system dot out dot println, and I will say counter value is, I will say like this. So I will say count. So this is my thread. So this is not my thread. This is what I want to do in parallel. This logic I want to execute in parallel. So now let's go ahead and create a class, main method class. So I will say thread main class. Let's do this, and here I will put the main method, public static void main, and then I will say string array, give it any name, array. And now what we used to do is we would basically, like any simple, we will create a reference of runnable interface. Let's say runnable is equal to new, the code that we want to run, the implementing class. So this is the implementing class, and then let's create a thread object, thread 1, and I will say equal to new thread, like this. And now I will I will do nothing but I will start thread one dot start. I will call the start method here. And now what will happen? Code. Let me also write some code for the main thread. So what I will do is this is the child thread. So counter value in child thread. Let me say child thread counter value. Let's put it this way. And now I will write the same logic, copy paste here in the main one. And I will say main thread, because this main thread counter value. Let me put it this way here. Because this is what? This is the main method. So this code is part of main thread. Only this code, which is getting started by this, which is here, is part of child thread. So I can similarly create, so I have to pass this runnable. Don't forget to pass this runnable into the thread, otherwise it won't create a thread. So now the thread got created on this runnable interface, and the implementing code, this one will get executed whenever the thread will start. So let's say now if I wanted to do something else, also another, something else as well in parallel. So I can keep running this activity thread one in multiple times in separate 2 times. But what I want is, if I want to perform another activity, then I will say create another implementing class, code to run as another thread, and then do the same here, and then create a new thread object and start that as well. So we can do 3, 4, 5 activities in parallel. But here I want to do only 2 activities in parallel. One is the main method activity, which is this one, and the activity which is present inside this. So if I now run the program, so this is how in Java 7 we used to do the thread implementation. So far we haven't converted this to multi-thread. So here it runs randomly. There is no sequence. So what it did is first ran all the main thread 1 to 5, and then it ran the child thread. So let me run it again. So now it's a different output. First main thread, then child thread, main thread, child thread. So you cannot predict which thread is going to get run first. It completely depends upon the JVM and the hardware and the scheduler, how they are going to coordinate between them. So now let's try to convert this into a lambda expression. So what you saw is we needed to create a separate class which would implement the runnable interface and provide definition to the run method, and then we use that here. So let's try to convert it into the lambda expression. So we already saw runnable interface is a function interface. Okay, so then we can basically create lambda expression for this. So what we will do, first thing, we don't need this at all, which means this whole class is not needed. This class can be deleted. You can delete it, but I will leave it for reference purpose. So if I don't have that class at all, how I am going to give the logic? So that's the power of runnable. So what we said, what we will do, we will go only copy the logic from here. We will copy this, and now here we will paste it. And as for the rules, we will remove the access modifier, we will remove the return type, we will remove the method name. We will put an arrow in between the declaration, and we will have to put a semicolon because it's a multi-line code. And now this has to be holded. Somebody should hold it. Who should hold it? Of course, the functional interface should hold it, because it is its responsibility. So now if you run this code, it is going to run exactly the same way. There is no difference at all. See, if I run again, then of course we'll get a different output because thread runs in different form, randomly. So we can easily convert a normal Java 7 form of implementation of interface method to Lambda expression. Great. So using Lambda expression, you saw how we can completely get rid of a class implementation, and we can just put the implementation here itself in a clean, concise manner. That's the power of Lambda expression.